First of all, I would like to thank the Schiller Institute and Lyndon LaRouche and Helga LaRouche personally for inviting me to speak at this prestigious conference. My prepared remarks begin with a historical overview, but some events occurred just yesterday which have changed my plan, and I shall begin therefore by telling you what happened yesterday. Yesterday was April 12th, which is marked in Russia and worldwide as Astronautics Day, because it was on April 12th in 1961 that the first man, Yuri Gagarin, made a flight into space. On this day, it became known that Russian Deputy Prime Minister Dmitry Rogozin has sent a letter to President Putin in which he proposes as a topic of the upcoming G20 summit the prevention of threats from space. Thank you. Secondly, President Putin announced that financing for the Russian space program will be increased by 2020 to 1.6 trillion rubles, which is quite a hefty figure and is essentially comparable with the NASA budget. So, after this short introduction, let me proceed to a characterization of the topic toward which Rogozin has proposed to shift the G20 agenda. This is the problem of the comet and asteroid threat. For quite a long time, mankind has been very sensitive to the existence of a threat from comets. Although asteroids, of course, were not yet in the picture, people were thinking about comets, which have quite a frightening appearance because of the tail. And for a long time, they were seen as bad omens. This is recorded even in the Sibylline books of ancient Rome. And closer to our day, in 1910, there was the first real panic connected with the approach of Halley's comet. And then a real panic broke out, mainly in Europe, but also in Russia, in America. There was a comet hysteria. There was a panic demand for anti-comet tablets and anti-comet umbrellas. But we made it safely through the tail of the comet. And mankind relaxed and let our guard down, thinking that the danger was behind us. But neither scientists, nor writers, nor fortune tellers had paid attention to the fact that 2 years earlier, in 1908, a more serious danger had actually confronted mankind. In central Siberia, in the Tunguska region, something exploded, something which may have originated with a comet. And this was a 40 to 50 megaton blast over the open taiga, and it destroyed over 200 square kilometers of forest. The consequences were felt even in Western Europe with a phosphorescent glow in the sky for several days. If the explosion had taken place 4 hours later, because of the rotation of the Earth, the city of St. Petersburg would have been totally destroyed and its historic palaces ruined, and who knows what the human casualties would have been. The scientist Vladimir Vernadsky, whose 150th anniversary we are marking this year, was extremely interested in this event and identified the Tunguska object not as an asteroid, but as a clump of space dust. and he gave great attention to the comet and asteroid threat. Under his impetus, there were several Russian scientific expeditions to the Tunguska region to look for the asteroid, the meteorite, and when they didn't find any shards, Vernadsky decided that it was dust. People still paid little attention because it was so far away, but in 1932, there was another meteorite strike which caused big fires in the jungle in Brazil. Even nearer to our time, in 1972, an asteroid of approximately 80 meters in diameter entered the Earth's atmosphere over the state of Utah. If it had collided with the Earth, the catastrophe would have been comparable with or greater than Tunguska, but it had the additional dimension that in 1972, such a strike, an incoming object, could have been taken as a missile attack and could have launched a world war. But fortunately, this meteorite jumped out of the atmosphere after 1,500 kilometers and departed. This year, in February, over Chelyabinsk, there was a meteoroid explosion causing 1,613 people to be injured, mainly by cuts from flying glass. This was approximately the size of a vehicle, about 17 meters in diameter. In the period of February 11th to 18th, there was an anomalously high number of meteorites observed in Russia, Kazakhstan, Australia, South Africa, Morocco, Switzerland, and other countries. It may be that the Earth's orbit at this period intersected a previously unknown meteor swarm. The fact that nobody had noticed this meteor swarm means that in February, we underwent a live test of our ability to identify space threats, and unfortunately, we flunked this test. Amazing as it might seem, the threat from the space, which was obvious for a long time before Chelyabinsk, was not taken seriously. There are perhaps some terrestrial political reasons for this. I think that if the SDI proposed by the USA under President Reagan, as Lyndon LaRouche has said, had it been developed, we would at least have by now an early warning system for space threats to Earth. This didn't happen. The Cold War ended. The United States, now lacking its main military adversary, essentially forgot about the SDI. A few projects related to SDI still exist and could be used to address problems of the comet and asteroid threat. However, there are only isolated teams in different countries working on the comet and asteroid threat. There are about 10 projects in various countries. These have made it possible to uncover 1,311 potentially hazardous asteroids, including things like the NASA Wide Field Infrared Survey Explorer. In Russia, there are also groups and organizations which have developed early detection technologies. The Russian Academy of Sciences Expert Working Group on Space Threats, which is directly under the head of the Russian Academy of Sciences Institute of Astronomy, Boris Shustov, And also the Lavuchkin Space Research Center is extremely important. Under contract with Roscosmos, there are special academy groups and others working on Aegis, AKO, and Apophis programs. My report is based on materials from these organizations. It is obvious that the comet and asteroid threat has two components. The first is improving the means of detection, and the second is actually defending the Earth. The first task can be solved for large space bodies like the asteroid Apophis. Here we have Apophis, which is going to approach the Earth in 2029 and 2036. But we are not absolutely certain that its orbit won't be changed by unknown factors and on the first pass and lead to a catastrophic collision on the second. But if we look at the total number of not yet discovered objects with a diameter of greater than 1 kilometer, like Apophis, Russian scientists estimate that they are fewer than 40 undiscovered, or 20% of the total undiscovered potentially dangerous space bodies inhabiting the solar system. Academician Shustov says that the total number of potentially threatening objects to the Earth, that there's 200 to 300,000 of them, and only 2% have been identified by astronomers so far. In order to find these lost objects, we need to improve the effectiveness of our detection system. First of all, we need to create a single planetary detection system. There are already existing elements, such as the Minor Planet Center, financed by NASA, the Jet Propulsion Laboratory of the USA, the University of Pisa Laboratory financed by the European Space Agency, and some elements in Russia. But we need more centers to encompass more of the Earth's surface. For example, we definitely need to have centers, stations in the southern hemisphere. Russia has different individual research groups which need to be united into a single information gathering system which will be part of a global network. And we need space-based telescopes like those being launched by NASA and the ESA. Financing is an important issue. After Chelyabinsk, academician Shustov at the Federation Council of the Russian Federation named the figure of 58 billion rubles, or around $2 billion, needed in Russia. This is comparable with some of NASA's more ambitious missions. Perhaps the Chelyabinsk events will help promote the funding. So far, most projects in space defense are passive, that is, detecting and counting. The only case of intervention on a space object was the deep impact experiment of bombarding the nucleus of the Temple 1 comet. Russian experts believe that there may have been a military purpose of these experiments because the experience of intercepting a 10 kilometer per second comet nucleus could be used in creating ballistic missile defenses. or in creating certain kinetic weapons, which have come to be known as rods from God. However, even if this is the case, there does not yet exist any fully confirmed mission for carrying out a retaliatory strike against an asteroid. The Apophis mission, which the Lavochkin Bureau is working on or has proposed, does not have a strict deadline or funding. Some time ago, Roscosmos leader Popovkin announced that NASA has proposed to Russia a joint project on catching an asteroid, about a 500-ton one, and taking it to lunar orbit or to a Lagrange point in the Earth-Moon system. Aviation Week has indicated that this is a non-confirmed project for which NASA was planning to allocate $100 million. The project was developed by the Keck Institute for Space Studies, and it provides for catching an asteroid using a special kind of bag and then putting it into the needed orbit, and this would cost about $3 billion. And it would look like this. To sum up, there are basically two main strategies: diversion and destruction. Of course, diversion is to be preferred, but there could be situations where you would have to go for destruction. And the means for diverting objects could be soft, that is, tractors or sails, and hard, like explosions, mining, and kinetic action. This could even include nuclear explosions. This creates political difficulties, since putting nuclear weapons in space could increase international tension and challenge planetary security. Therefore, we have to be talking about a supranational project under the UN aegis, and this is the nature of Dmitry Rogozin's proposals, which he has been making even back when he was Russia's representative to NATO. The latest we know about is his letter to Putin from yesterday. Rogozin has proposed to create a global strategic defense of the Earth from space threats, whether of man-made or natural origin. Rogozin underscores that this initiative would allow Russia to seize the initiative from the United States in the global missile defense framework like the Euro-BMD, but it also would eliminate one of the main confrontation points between Russia and the United States. It could also be combined with a truly single and joint Euro-BMD system together with a civilian project for space exploration. Russia has something to offer for a global defense system. Mainly, we're talking about systems developed by the Lavochkin Center, such as the Citadel. This was developed on paper 15 years ago, and it was considered that it would take 7 or 8 years to implement it. However, there was no political decision taken on doing this. It would have allowed interagency cooperation, which was not available at that time. This is a complex echelon system with fairly elementary basic components. Almost all of these basic elements or their prototypes were already developed in the Soviet period. This includes space interceptors and space intelligence gathering machines. Also relevant, these apparatuses are similar to the small ones developed by the United States under the Clementine program, which was part of the SDI. They're very lightweight. They can be delivered at high speed to potentially dangerous objects. These would be mounted on the dangerous approaching objects. And then they could receive commands to either divert or destroy through either a nuclear explosion or a kinetic strike. The main thing Russia can offer in this regard is the Citadel echelon response system, and this would rely on launchers that already exist using ballistic missiles, that is, a converted ICBM, the one known as the SS-18, the biggest ICBM ever built. The converted version of this launcher is called the Dnieper, and it can be launched with a few minutes lead time. The Zenith system can be launched in an hour and a half. This is a very good fast response result. This makes them essentially the only rapid response launch systems in the world. The Zenith can deliver, for example, 1.5 tons payload to an asteroid. This would be enough to destroy an asteroid up to several hundred meters in diameter. At first, it was thought that the Mars 96 and Phobos Grunt spacecraft developed by Lavochkin could be used for asteroid defense, but there were several test failures. But if the Citadel system were implemented, there are several Lavochkin spacecraft that could be used, or the Russian launchers could be combined with NASA and ESA spacecraft. It's clear that the countries involved are going to be those which have nuclear delivery systems and weapons: Russia, USA, Western Europe, China, Japan, and Ukraine, India. This means that a successful program needs to be developed which is planet-wide to defend against space threats. This shifts the task into the political domain. We must develop an effective strategy for the systemic detection of situations threatening the existence of human civilization. Otherwise, we have an increasing danger from year to year, because in the last 100 years we've been awfully lucky. Otherwise, humanity is going to be playing Russian roulette with the cosmos, and as we know, you cannot win that game every time.